Hey everyone, Ernie Costa, what's up? It's been a while. Unfortunately, not much news over the last couple months in the Microsoft world. Sure, there's been a lot of things kind of fake announced and hinted at over the past few months at things like Inspire and Build. But we're really hoping at Microsoft Ignite this November, it's going to open up the news world a little bit, and we're going to get a lot more info on cool stuff that's coming in the Windows Server and Azure world. One thing is for sure. The biggest thing we are waiting for is more news on AVD for HCI. We've done a few videos in the past on AVD for HCI showing some basic manual deployment steps, but ultimately we're still waiting on improvements for things like Resource Bridge and VM self-service to make this seamless. So while we're waiting, we're going to take the opportunity to talk about how some of the technologies behind AVD for HCI and even AVD in public Azure cloud can help you improve your workload experiences. These are going to be things that are already available or maybe in public preview, so that when we are ready to go GA with AVD HCI, you can have a game plan on how to implement them and make your experience better. So let's jump in. All right. First, and arguably the most important of these technologies to make your AVD and AVD HCI experience better is RDP Shortpath. But before we get into what RDP Shortpath actually is, let's talk a little bit about how AVD sessions are actually established in the first place. First of all, you must be using the Microsoft Remote Desktop Client, which is commonly called MSRDC. So I'm going to use that acronym for the rest of this video. This is a lot different than the old MSTSC application that you are probably familiar with that comes baked into the Windows OS. There's a ton of improvements and features that are in MSRDC that aren't in TSC that allow these optimizations to occur. There's also integrations into other Microsoft products like Microsoft Teams that allow these optimizations to occur seamlessly with very little user interaction. Again, these are things that are not in the old MSTSC app that you're familiar with that comes installed with your Windows OS. So you're going to need to go out, you're going to need to either Google search or we'll supply a link in the bottom here of this in the video description on how to get the MSRDC app. And the cool thing is there's a lot of cross-platform versions of this. Obviously, there's the Windows binary. There's even a Windows Store version. I think they call that the Azure Virtual Desktop client for some reason for branding or marketing purposes. But there is a store version. I personally don't recommend it. I like the thick traditional Windows binary that you install yourself. It's an MSI. There's also a application for Mac OS. So hop into the App Store, do a search. There's also clients for iOS, obviously, naturally with Mac OS. The iOS client is actually really cool. I use it a lot on my iPhone. And then there's also an MSRDC build for Android. And then lastly, there's a HTML5 kind of like in your browser client that's built with some of these technologies. It's probably the most limited out of all of these, but it is available in a pinch. I've used it in a Tesla browser before. I've used it on like a library kiosk once to do something real quick in incognito mode. It's there. It's available for your Linux users if they don't want to, futz around with maybe trying to get an Android emulator up and running. It is an option. Second, you must understand that AVD and AVD for HCI differs than traditional remote desktop, meaning you're not just directly connecting to the terminal service. That's a mouthful, but the term serve service that lives in the Windows server itself. You're not connecting to that directly. You're actually going to be leveraging something that is established through the Azure backplane. There is a small guest agent that gets installed on your VM. I believe it's called the side-by-side stack. It is a separate set of technologies that coordinate these connections between you running MSRDC and also your kind of connection you're making from the Azure backplane. That may be a little confusing without drawing it out. That agent service that's running actually establishes if you want to call it a reverse tunnel, it establishes a connection into Azure public cloud, depending on your geographical location, that is kind of a backplane. You could think of it like like a reverse proxy or a reverse tunnel. This is the thing that tells Azure some other than just like connectivity. It tells Azure like health information. It also runs in tandem with an Azure Arc agent that gets installed on your VM. And that's going to be what's reporting back metrics for like log analytics and other health things that just come along with the Arc experience. Um, Combine it's these two agents allow the magic to happen. So again, you can't just spin up a Windows server or Windows 10 machine. You need to install these agents. So MSRDC to connect, these agents installed on your session host VM to actually do the communication into the cloud. So, all right, now that you got a cursory understanding of how the VM itself connects into the Azure backplane, let's chat about how you connect to the VM from your local machine. Again, using the MSRDC client to connect to either AVD HCI or AVD, your local machine establishes a connection first to this Azure AVD backplane itself. It's kind of like a remote desktop gateway, but it's got a lot more features and smarts specific to AVD usage. That connection is established over TCP, which is great and normal, but there is some overhead involved naturally with TCP. TCP requires every packet to be acknowledged, which means that if there's packet loss due to latency or maybe like really bad bandwidth or just whatever, your RDP session will appear to freeze or like lock up or lag behind what you're actually trying to do. For most usage, real world usage with like text manipulation or like maybe just like browsing it, like, again, a text website in a browser, may not be the end of the world. But if you're doing graphical type of work, any kind of like three-dimensional rendering or even just like manipulating bitmaps, 2D imagery, that latency will be very impactful. You'll feel it. Like there will be, other than just like the latency of click, wait, actually having a delay and outright screen freeze is super like annoying. If you've ever experienced this, maybe like while typing or maybe manipulating an RDP session inside an AVD session, where the session itself locks up and you're waiting and you're clicking, or maybe you type too much in the keyboard, you can completely bugger up your work that you're on. So obviously this is not a great thing to have to deal with. Thankfully, there are workarounds to help mitigate this. Microsoft influenced RDP over UDP years ago in traditional RDP and remote desktop session hosts, but you typically have to have some kind of network firewall rules enabled to allow this to happen at your edge, to allow people to reach in. So, like on a private network, establishing a UDP connection is trivial. It's especially if you're on the same network segment and you don't have to traverse a firewall. But when you're dealing with internet connectivity, you're probably using an RD session gateway, an RDP gateway to handle that. So there's some firewall rules you need to open. So for AVD, that's a little bit more complicated. Again, because you make that initial connection into the cloud, how does that all work? So Microsoft has implemented something called RDP Shortpath to handle that. A lot of black magic that kind of happens under the hood. The long and short of it is the beauty of the MSRDC application is it has, again, those smarts built into it to allow you to kind of handle a negotiation between your machine that's local to you, maybe your laptop or your iPhone, and your VM that has a connection established into the Azure backplane itself, so that once both things are kind of there, it hands off a direct UDP connection if capable. You're probably asking, how is that capable? Again, you still need to open up some firewall ports to make this happen, but it's not a direct UDP open connection. In other words, you're not saying, hey, network team, just blast firewall rules and allow port 3390 to all these VMs on-prem. Instead, you're doing the reverse of that. You're opening UDP ports up to egress out. So in other words, allowing your session host to make connections to the Azure backplane over UDP. So then those that middleman that's sitting in the cloud can establish that direct machine, that direct handshake and connection, and you're able to connect. Sometimes this isn't doable though. Like you just literally can't do it because maybe you're in a situation where you're double or triple natting. If you don't know what that means, it basically means you have a router behind a router. And you see this commonly with like maybe internet service providers who give you their own gateway. Like let's say you're using Comcast Business, it's coaxial cable. If you're in the United States, you're not familiar with it. There's probably analogous service providers out with the rest of the world. They give you a gateway and you can't do direct bridge mode from that gateway. Like you need to use their router. It has its own private LAN segment, and then you have to plug in your network gear to it, typically behind another LAN segment. So you're double natting there. Um, the packets wouldn't know how to get out properly. Maybe you can't open up those firewall rules on the ISP's gateway device, or even another extreme situation, triple natting or carrier grade natting, which occurs if you're using maybe a cell service provider. Again, in the United States, T-Mobile has a home 5G internet package where you get a nice little trash can looking router modem device. It's wonderful. I use it. I'm actually using it at home right now. But you are sitting, because they have limited IPv4 space, you're sitting behind multiple layers of natting at their like cell tower level, and their whatever the heck they're doing in the backplane on their end. So again, you can't like open up firewall rules because you don't really have a real public IP address. So there's some limitations there when it comes to just traditional RDP shortpath. Microsoft has a workaround for this as well. That workaround is RDP shortpath over relay, or like UDP over proxy, or UDP over indirect relay. I forget what the actual terminology they or marketing, mumbo jumbo they call it, but it's basically a UDP session that's established indirectly by using a relay in the middle, via something called a turn server. Turn as in TURN. It's an acronym. The turn protocol is used frequently for other technologies to get around this asymmetrical triple natting situation where you may not be able to just blast firewall rules. And it still establishes a UDP connection, just not a direct blasting UDP data packets, not really packets, but blasting UDP network data to the machine directly. There's a relay in the middle that kind of intercepts those and does the deed for you. It's still happening over UDP, but there is a middleman in between. And you're probably wondering, why is that better than TCP where there's a middleman? The answer is because UDP does not need those acknowledged packets that we mentioned before. Again, we can spend a lot of time talking about TCP versus UDP, but the long and short of it is UDP allows for there to be latency and packet loss, datagram loss if you want to be serious. But if that network data for whatever reason can't get to the machine because of latency, poor signal quality, maybe using satellite internet, you're not going to end up having this session that just freezes because it's expecting a return acknowledgement. UDP is fire and forget. If it goes out of order or it's not acknowledged, the session itself isn't going to crap itself unless there's like, multiple seconds or minutes of those datagrams not making it there. So what we're going to do now is we're going to kind of just like intermux in another video I found on YouTube. Gentleman did a great job at recording, I think it's Microsoft Flight Simulator, running like the demo of Microsoft Flight Sim, basically on his local machine. Recorded that because it's like a known rendering, and then doing the same thing by RDPing in to the machine over AVD using TCP, or also known as WebSocket, and also using RDP shortpath. So the session is established over UDP, and you're going to see like right away. Obviously, the bottom image is like the pure rendering happening locally, and then the top two images are going to show you the two different technologies. You're going to see right away like the UDP session is pretty much like in lockstep with the legit video recording. The TCP session, you're going to see some artifacting, you're going to see lockups, you're going to see freezing. You're especially going to see it when it comes to like major scene changes, because there's like a complete redraw that has to occur in the entire video memory for them to render a large chunk instead of just like its and bits and pixels changing here and there. The whole dang thing has to be recompressed and JPEG'd or whatever magic is going on back in the, not a video encoding expert, but you can see when the actual latency occurs based on what's going on in the video. It's really cool. We're going to supply a link to this video in the description so that you can actually click and watch it to get a better view other than me just interpolating it here. Um, Definitely an eye-opening thing that will greatly improve your experience. Okay, so let's chat a little bit now about what your end users are actually going to be doing inside the AVD session host. Realize that AVD for HCI is probably going to be replacing your end user's physical devices, whether that's a laptop or a desktop. That means if they're using software like Microsoft Teams for voice and video calls, you're going to want the best experience for them. And I can tell you firsthand that not having a solid and a solid connection to these voice and video calls is going to be the biggest headache for some of these users. They're going to complain about that more than anything, especially if their home internet isn't great. Thankfully, MS Teams, in conjunction with that MSRDC application we spoke about earlier, they have the ability to talk to each other with some built-in improvements and kind of sidestepping tweaks to make this experience really good. And it's called the WebRTC Redirector client. That's going to be explained in a video I recorded earlier. I'm going to intercut it into here just to kind of demonstrate what it looks like, what it is, how to install it. Very simple. If you have a lot of users using your AVD session host for Microsoft Teams, um, that video interaction is kind of important. Like obviously you can do voice calls, you can do you can just chat, but doing a video call obviously is pretty important. And you can see like right now the quality of the video of me, which is being recorded through my web camera and directly through OBS, just common screen recording software. Like it's pretty sharp. It's like 60 frames per second. Resolution's good. Like you don't see any artifacting other than maybe like the YouTube compression if you're watching this on a low resolution. But generally speaking, like this is a pretty crisp looking video. So if I were to open up Teams on here and start a call with myself, so I call my cell phone. Let's actually kick that off through my cell phone. Let's see if I can do this. Come on, baby. There we go. I'm gonna see a call pop up. There it is. Answer it. Oh, there I am. Little weird. I'm gonna mute this. There we go. And you can see like the quality of this video may look a little grainy, and uh, I'm on Wi-Fi on my phone, and like you probably shouldn't be expecting like high def, but like like look at that. Not too great. Like a lot of JPEG artifacting, a lot of ghosting, frames per second's pretty garbage. And that's happening because there's a video on my phone that has to go to whether through 5G or cellular or Wi-Fi and connected, it has to make its way to Azure somewhere, and do its compression and then come down to the Teams client that is making the call, which is this VM that we're screen recording. And because it's AVD, because it's remote desktop, there's some deficiencies that happen there. There's no GPU on this VM. So this is the CPU is strictly decoding. Actually, let's see if I can pop open Task Manager and see what the VM is struggling. You can see that the dang thing is chugging 50% CPU, and yeah, probably a problem. If we're going to show more demos later of what happens when you try to watch something without a GPU. CPU basically just pegs itself. So actually, let's see if I rotate this thing. Ooh, look at that. So now we have this really um, big big picture of me. And again, like look at that. Just tons of artifacting. It works, but not really that great. So how can we improve that? Let's kill this. Um, Cool thing is built into the MSRDC client. That's the thing you use to connect to this VM. And look, you can actually see the CPU has dropped dramatically just by not having that video on the screen anymore at 1080p. But there is there's some improvements, or I should say, there's some performance tweaks made built into the MSRDC client that allow you to offload some things that Microsoft has their grimy hands on, things like Teams. For example, they've baked in some improvements, but you need to have some stuff installed on your VM in order to get them. So the WebRTC um, uh, client, I think is just the WebRTC client, is one of those things. It's a piece of software that gets installed side by side with Teams, and it allows you to offload some technologies to improve this experience. You also need a AVD optimized install of Teams, and you can check if you have that by just going to Teams, clicking on these three dots, going to About, and going to Version, and you get this little modal up here. I'm on the latest and greatest. If I were to copy and paste this build number into Google and search for it, you'll see that this is the latest version of the public release of Microsoft Teams. It may even be like I don't even think there's a private release that I know of, at least that's out. It was literally installed today. So this is the latest version. But this is not what you call the AVD optimized version of Teams. In order to install that, you have to install the machine-wide installer of Teams. So you can't just go to the Teams website and download for work and business. You need to download a different MSI. Include some flags when you go to install that MSI that basically says like, hey, install this for all users. Oh, and by the way, this is an AVD VM, VDI instance, because it's not just limited to AVD. It's any kind of virtual desktop infrastructure can get these optimizations. So I'm going to pull up those steps now. It's going to magically just kind of skip ahead here to make this a little simpler for myself. Magically pulled up the two docs pages here. The first one, so I had called it the WebRTC client. It's not. It's WebRTC Redirector service. If you Google that, you'll end up ending up on the virtual desktop Teams for AVD docs page, and they basically explain to you that, hey, in order to do this, you need to do a couple things. You need to set a registry key, which they're so kind and they give you the PowerShell. So we're going to do that real quick. We're just going to copy this PowerShell in here. This registry key basic it creates a is WVD environment D word. It sets the value to 1, and then that's it. That's all you got to do for that. The second step is installing the WebRTC Redirector service itself. So we're gonna download this. It's tiny. It's like 2 meg. We're gonna open it up. We're gonna install it. Yep. Now the beautiful thing is if you're prepping a gold image for your VDI instance, like let's say you're gonna sys prep this later and you're in audit mode, you can install all this stuff ahead of time so that it's there pre-deployment. If you're going to spit out 100, 200, 1,000 of these, so that's a good thing. So that's installed, great, super lightweight. And then the last thing is actually installing Teams on the AVD session host with those very special keys. So you can see I already downloaded the Teams MSI here. And reading the instructions, it says, download the one that matches your environment, obviously around a 64-bit operating system, and then run the following commands. This is what's important. These two flags right here, and they were so intelligently made to be as confusing as possible. One of them is called all user, and then the other one is called all users, plural with an S. Uh, they go into detail here and explain what the difference is between the two. Um, the long and short of it is, you need both of them in order to uh, enable the AVD optimized version of Teams and also prep this image if it's going to be sys prepped and massively deployed out. Because if you don't specify the all users with an S, plural, when you go to sys prep it, it's only going to install Teams otherwise in the local users app data directory, I think. So by installing it with that second flag, you end up getting it installed in program files. So we're going to run that now. We ran that. Teams is installing. I'm not 1,000% sure, but I did flip over to CMD and actually run that and not PowerShell, and it worked. So it may have something to do with the slashes versus the dashes and how the arguments were passed in. Just keep that in mind. And I think it's installed at this point. Like I literally think it's a silent installation. If I scroll down, there's Teams. And just to show you, if I go to installed apps, I think it's in here. And we scroll down, scroll down, scroll down. We're going to see Teams machine-wide installer right here. So yeah. So as mentioned earlier, this is a non-user specific installation. It's installed for everyone. Coincidentally, the build is the same number. More on that in a minute. And then now we're going to launch Teams. All right, Teams is open. Just confirm that we are on the AVD Media Optimized version. Awesome, good deal. Let's kill our remote desktop session real quick. I'm going to literally log off because I have a suspicion that the MSRDC client that we're RDP'd in with doesn't know that there's this new side channel that it can use to offload video. So we're going to log off real quick. And we're logged back in. Editing. Launching Teams. It should still say optimized. It does. All right, so we're going to make our call. I'm going to, before I do that, let's go into settings and just make sure under devices, that's my microphone. There's my webcam. So you can see, this is me. This is my camera on my physical laptop connected to the laptop, connected over RDP to my VM. And you can see it's pretty good compared to like you're seeing it captured inside the VM. So there's redirection going on here where that video is actually not rendering inside the AVD VM itself. It's happening local, and the MSRDC client is kind of doing some black magic to keep it to keep it in the piece of the bitmap where it needs to be. So we're gonna call me, and I am getting call my cell phone. There it is, Bob Dole. I'm gonna hit yes, and I'm gonna pick this up. We're gonna mute that, and damn, I look good. That is some high quality H2O right there. I'm actually with my iPhone. I'm going to hit the record button and record the actual iPhone itself. Um, let's see if I can turn this on. So I'm not going to look that great on the iPhone because there's nothing we can do about that. The iPhone's not going to offload it. Maybe if I had a GPU, it would look better. But so we'll turn that off, and and I'll stitch it into this video where I'm actually moving pretty good. Like I look great considering like this is making its way through like 100 different things through various forms of redirection and sending up on my cell phone. So we're going to hang up, and now I'm going to go back and I'm going to uninstall the um, the RTC agent that like makes this actually happen. So let's go into settings, apps, apps, Teams, RTC, da da da. I guess I can, oh, there it is. I just saw it, WebRTC. All right, I'll uninstall this. And it probably wants Teams to be killed, which it looks like it did automatically for me. Yep, there it goes. Cool. And now we're going to relaunch Teams. All right, now that we launched, let's call me. And you can tell already, like, just look at that. It's blurry, it's artifacty, it's grainy. I'm going to pick up on my phone. and again, I'm, you can't see this, but I'm looking at me and it's grainy, it's artifacty. I'm, yeah, it doesn't look great. I'm gonna record this on my iPhone and we're gonna see if we can do a little comparison side by side. It may be difficult, but you can see like there's a lot of JPEG artifacting there, frame rate drops, and you can see in me in the bottom right corner, um, it's not great. And if I were to go to, um, if I were to just pop this up, devices, you can see it's like it just looks like garbage. So let's keep it, let's try to give your end users the best experience possible here. So depending on your users, you may have the need to stream videos inside your AVD VM. Just maybe watching content on YouTube or any number of multimedia sharing websites. And without a GPU, that can be really intensive, especially I'll show you. I actually have a 1080p video loaded up, and it is the famous Big Buck Bunny. And you can see it's already chugging my CPU on the VM, so much so that the audio is probably going out of sync on this video that you're watching of me. So we know already what's going to happen here. Like this is just going to be a terrible experience, especially in action sequences. You're going to see some artifacting. You're going to see frame rate drop. It's going to be atrocious. And it's difficult to capture with a screen capture. It's like you kind of see there, like these credits are jittery. There's like a bunch of like frame drops going on. So we're gonna pause this and we're gonna talk more about how to fix this. At least offload it without needing a GPU on your session host. Two components to get this done. The first one, install this Multimedia Redirector host redirection service. It's a lightweight MSI. We're going to go in, we're going to click to install it. It literally takes a half a second to install. You're putting this on the AVD VM itself. And secondly, you're installing this browser extension. This is only for Edge and Chrome right now. So any Chromium-based browser you'll probably be able to get away with if it's some weird flavor that doesn't fit those two names. If you scroll down enough, you'll see install the browser extension manually. I'm using Edge, obviously. Again, you're installing this extension inside your AVD VM. So I've already gone ahead and clicked this and install it. You can see that I have it enabled here, the Microsoft Multimedia Redirection service. Let's go back now. Let's kill Edge. And I bookmarked the video that we just watched. And just to make sure, we're going to crank this baby up to 1080p, 60 frames per second, and we're going to kick it off. And you can see already the video is being redirected. You may not be able to see it in the video capture, but there's some additional, like right there, you can see there's some artifacting that's kind of going on because of the transparency effects with YouTube. When you like put your mouse over a video and it shows you the scroll bar and stuff. But you can see already, like the frames per second is pretty damn good. It's like 60 frames per second. And that's because this is offloading it to your actual machine where you're connected to. So it's using redirections. This is a great example. Frame rate is pretty steady. No jitter on the credits. Very cool. And again, this is working through MSRDC optimizations that they've made in your client. And let's turn that on again. And if we look at the CPU usage, not really going to spike that much. Kind of hovers on a 30, 40, 50%, which if I wasn't using this, it would be pegged at 100. Again, because it's actually occurring on my machine that I am RDP'd in from. So kind of cool if you don't want to splurge on GPU and you're doing some HTML5 based video viewing. I think Twitter works on this. I think there's a bunch of other sites that it works. Then there's unofficial support that you can go in and um, you can actually like manage the extension and turn it on for all sites versus specific sites. You can turn it on for like you have to click the video to turn it on. So you can play around with it. Like I said, there is some weird, like you can see right here on his belly how there's like this weird transparency effect. If I move the mouse over or if I start the video, it goes away. That's just like a YouTube thing. I don't know what to say about it. But generally speaking, pretty darn good. I think Microsoft also builds this as a way to watch Teams live events in your VM. Um, there are scenarios where like you can't watch the live event with normal Teams and even with the optimizations that you do with Teams because of the way Teams live events is captured through like real-time streaming protocol or something. So what they recommend is you launch Teams in the browser, and because in the browser it's an HTML5 video element, you can then use the MMR extension to offload that, and you end up it's a little sidebar to watch those live events. Again, don't know how often that actually happens, but it is good to know. So there you have it, folks. Three very interesting, kind of exciting ways to implement some improvements into your AVD environment. Again, whether AVD on HCI or in the public cloud. So we're looking forward to you giving a little feedback about how this may or may not have helped you. If you have any ideas, recommendations, and we're also looking forward to some more AVD announcements in the very near future from Microsoft. As soon as we know more, we are going to spend a lot of time talking about all of it. So thank you for coming and stopping by.